So before looking at building and fine-tuning an LLM, we have to understand a bit of history of how this came about. And initially, there were only the neural networks, which is really famous in the data science world, which you might have already heard about. But there is also recurrent neural networks, and it solved an important problem that neural networks faced. So neural networks did not have capability of holding on to memory. So recurrent neural networks was created to solve this lack of memorization capabilities that was actually missing in the neural network. So here we have a neural network. You can see the input layer, the hidden layers, and the final output layer. And this is how a recurrent neural network is represented. And you can see here within the hidden layer, there is a feedback loop going on, which actually creates this memorization. But that doesn't mean recurrent neural networks are perfect. As you'll see next, there are a few disadvantages which has led to building of more complicated models. So RNN, again, to summarize, is a specific type of neural networks that have the ability to retain memory. And this we consider as the first step towards modeling natural language consisting or by considering the time dependency between words. And one of the types of RNNs is actually LSTM, which is long short-term memory networks, and it is good at modeling sequential data. And the output of this recurrent neural network depend on the prior elements within the sequence. So imagine this was our sequence where we have recurrent neural networks don't have the ability to understand time. So if this was a sequence, then this word neural actually depends on what comes before it, which is regular, and the network depends on the previous word, which is neural, and so on. So we have memory of just one word before we predict the next word. So if we were to unpack this statement a bit more, so we have recurrent neural networks, but they don't have ability to understand time. So they're not able to create dependency between words. So recurrent neural networks only looks at the word that came before it, but it's not able to look at the entire sentence, if you will, and it's not able to create that dependency between words. And here is the biggest disadvantage, which is it assumes that the input and outputs are independent of each other, but in text or natural language, that isn't the case. So here we have another representation of a regular neural network, or also known as a feed-forward network, where we have all the inputs and the hidden layers and the outputs. So all the inputs are given at a time in parallel, and then they go through the process and we get an output. And we'll see what these neural networks are good for. But at least when it comes to natural language, we need some sort of memory. And that is what we see here in recurrent neural networks, where within the hidden layer, we have this sort of a feedback loop, which creates an effect of having memory.